Master of Disaster. Hello.
Hello. Hello, everyone.
We are live now.
Yes, we are live. We will shortly check if everything is working, if you folks can hear us, and as soon as we got the information that it's working. So great. Let's kick off day 2 of Agile and Automation Afternoons. Again, welcome everyone. Great to have you with us today. And we will start with day 2, but maybe before that, let's maybe introduce ourselves. I'm Michał Kujawowicz.
And I'm Alexandra Kulnish. And this is the second day of Agile and Automation Afternoons. So previously it was the Agile and Automation Days. So it was the full-time conference focused on the topics related to the software quality. So you could find the good practices heavily used among the industry, but also the cutting-edge technologies and tools. And this year, because of the world's situation, we had limited options, but we still wanted to organize the international conference. That's why we went online, and to let you still attend the conference in the form of 2 afternoons and still listen to great talks and discussions. And more than 300 people registered, so we stay the same in the size. Hopefully the next year will be even bigger and hopefully offline.
Yes.
Michał, do you want to say something more about the schedule and other plans?
Yeah, so maybe before the schedule, we already have a date planned, so like book it in 20th and 21st of September 2021. We plan a physical version then of the conference, so like book it in. We hope to see you all then in Poznań. If you want to be on top of what the updates, how is it going, please follow us on Facebook and Twitter. There will be all the relevant and most important information. And we would like to, of course, to thank our organizer, 21CN, the company that stands behind this event, and our main partner, testerzy.pl, for giving this opportunity to organize Agile and Automation Afternoons. So let's hop onto the schedule of the day. We have 3 presentations today. We will kick off with a presentation of Andrei Tognolo, who will talk about the challenge of testing 300 services in the wild, in production, not in production, but 300 services in production, but testing throughout the life cycle. And next, we will have Anna Radzikowska telling us a little bit about how the evolutionary change works, how to best prepare ourselves for that. Then we will have a short break, 15 minutes break, and we will have next presentation at 7 p.m. with Olga Maciaszek-Sharma to tell us about better APIs and faster tests, more resilient systems with Spring Cloud Contract. And we will wrap up sometime around 8 p.m. So without any more delays, let me introduce our first speaker for today, Andrei Tognolo. Andrei, am I correct? You're joining us from London. Welcome.
Yes, thank you very much. I'm joining from London.
Great. So I'm excited to welcome Andrei, and he is tech lead of engineering experience team at TransferWise. He has over 13 years of experience, worked for many companies focused on agile methodologies and testing. The companies like Dextra, Systemas, ThoughtWorks. And Andrei will talk about challenges of testing of a system consisting of many services. He will probably say how many of those they have right now. Great to have you, Andrei, today. Are you ready? Can we kick off?
Yes, I'm ready.
Okay.
Thank you very much.
So let me turn on your presentation, and the stage is yours.
Cool. Thank you very much. Thank you very much for joining us today. Today I'll be talking about Test at TransferWise, the challenge to test a system with more than 300 services. As you already know, I'm André Tonhola. I'm the tech lead of the engineering experience. I worked for TransferWise for around 4 years. And before I get into the content of this presentation, I think that I will give a couple of disclaimers. So first of all, by no means things are perfect at TransferWise. If that's what you expect, I'm sorry to disappoint you. We'll be talking a lot about the challenge, a couple of alternatives that we've been trying, and some that are working, but by no means things are perfect there. And also, we have different views across the company. So you cannot expect that everyone in TransferWise has the same view. What I'm going to be showing here is what I believe that kind of the direction that most of the teams they are going, but we have highly autonomous teams. So each one of the teams, they actually can define their own strategy for testing. And also we are in a journey, and we are looking for engineers to join us in this journey. So if you would like to know more about the open positions that we have, I'll be very happy to talk with you. You can contact me on Twitter or even send me an email. I'll be very happy to talk with you. I would like to present you TransferWise in case you don't know who we are. Our mission is money without borders, instant, convenient, transparent, and eventually free. We started basically as a company for you to send money abroad from one currency to another. Nowadays, we have other products. For example, you can hold money in different currencies. And also you can spend the money that you have in your balance using our plastic card. Currently, we have over 8 million people using TransferWise. We process more than 4 billion transactions every month. So you can imagine that tests are very important for us. From a technical perspective, we have more than 400 engineers, more than 350 services, and our stack is mostly JVM. We run our infrastructure on Kubernetes. We use Kafka a lot, and we have a mix of different databases. So the agenda that I prepared for this talk is basically we start talking about the testing strategy in a monolithic architecture, trying to identify what are the things that we can use and what are the things that we actually should try to leave behind from this type of system. Then after that, we'll be talking about how to define a testing strategy. And then we'll be talking about the testing strategy at TransferWise, where it will be split into 3 topics: the intra-service testing, testing production, and on-demand production-like environment. So getting straight into the testing strategy in a monolithic architecture, I think that it was quite common for the monolithic architectures to have some sort of testing strategy like this. You have your coding, you're doing your coding, then you push your code, your change to GitHub, then your continuous integration environment here represented by Circle CI, you run some automated tests, then from there you get a deployable that you deploy in a staging environment, enterprise-wide test environment, where you run some exploratory testing. Then after that, you promote this version to production once you see that everything is working fine. Now I want to talk a little bit more in depth here about 2 of these steps that I think are important. First is the automated tests. So if you think about the automated tests that we run, I think we can classify them into 2 groups. The inter-component tests, those tests that you only need one component to run, and the cross-component tests. You need more than one component to run, for example, for your end-to-end tests. And although we can say that the monolithic architecture has many disadvantages, I think we need to recognize that there was a couple of things that were actually easier with a monolithic architecture. And one of the things is the fact that when you're running these cross-component tests, it's much easier because you actually have all your components bundled together. The other part that I want to talk about this kind of testing strategy is this staging environment where we'll be running exploratory testing. One thing that was quite common is you have your component that you're working, your team is working on one feature, you deploy to staging, you do some tests there, and you see that it's actually working. And then you say, okay, cool, I want to promote this version to production. But then what happens is that there's another team doing something totally unrelated with what you're doing, and then actually they found a bug in what they are developing. And then at this moment, you are basically blocked by another team that has no relation with you. And then we have many techniques to try to avoid these kind of situations. But at some point, we got tired of it. I mean, we said, you know what? What if we split our monolith into smaller services? So if you think, one of the main advantages of the microservices is the ability to deploy one service by itself, independently of the others. And it's very important for us to pay attention to this principle, because if you think about testing strategy that goes against this principle, it's possible that we end up in an architecture where we are actually not using the main advantage of microservice. So if you think now how we would evolve that testing strategy from a monolithic architecture to a microservice, we're thinking about the service having an independent path to production. So each one of the services, which previously were, let's say, the components, now they are services. Each one of the services, they have its own integration environment. Now, if you think about the two categories of service that we previously mentioned, they changed a little bit. We're not talking about components, we're talking about services. And if you think about the inter-service test, it's pretty fine. You can still perform them in your continuous integration environment, but how about the cross-service tests? That's when things get a little bit more complex, like, for example, your end-to-end tests, because now you depend on multiple services. And while we could say, like, okay, I just need to bring these three services up in my continuous integration environment, that might be true for 3 services, but how about the 300 services that we will want to have? Now, because you cannot really run the cross-service testing in your continuous integration for each one of the services, one solution that's quite common for people to come up with is, let's still run our inter-service test in each one of the continuous integration environment of the service, but also let's have an environment, which I'm calling here a stage environment, where we are going to have all the services there, and then we'll be able to perform cross-service tests. And then my question for you is this a good testing strategy for a microservice architecture? The way that I try to frame every time that I see a testing strategy, if it's a good strategy or not, I try to pay attention to the hardest part of the testing strategy. The hardest part is the given. And we tend to neglect the given, I would say. When I say the given, what I mean is that each test that we perform, either automated or manual, we can split into 3 steps. Given that I have something, when something happens, then we're going to expect something. And the given for this kind of testing strategy is actually pretty hard to achieve. So what is the given? It's given that I have a production-like environment, and by its own, that's like really hard to achieve. But it goes beyond that, where all the other services are working properly. What I mean by that is you have this environment where you have all the services there, and you have the service A, and you have a new version to test. And what the service A is expecting is that all the rest of the services, they are working fine. But at the same time, someone else is trying to test the service B. And now they're expecting the same. They're expecting that the service A is actually in a stable version, which it's not. So we end up in a situation that is actually, it's quite brittle, this environment. And that applies for both manual and automated tests. So basically, what the message that I'm trying to convey here is that this idea of having an enterprise-wide testing environment does not seem like a good idea for microservices. And I'm not the only one saying that. If you look ThoughtWorks Tech Creator, in 2017, they are already putting the enterprise-wide integration test environments in hold. And then the question that arises is that, okay, if we used to have the enterprise-wide testing environment, you need telling me that we need to be cautious about using them, we should try to avoid, then what is my alternative? Which brings us to the second point, which is how to define a testing strategy. And there are like many ways of defining a testing strategy, I believe, but I think that we could all agree that there's no silver bullet, or at least we haven't found one. Then what I think that we should actually be asking is, what are the most common incidents in your company? Because each one of the companies, they are going to have different needs. The needs of TransferWise is different than the needs of other companies. And if you think about TransferWise, what we've been trying to do is that we've been trying to make it easy to report and coordinate incidents. So for example, we have a Slack bot where you can easily say that there's an incident happening. You can report an incident. You can say what is happening, and you can put the teams which are involved in this incident. It's going to create a Slack channel, and it will also notify the people on call for those services. And then based on the things that we get from this incident, we have weekly meetings to discuss the most important ones. And then on top of that, we also collect metrics. For example, the rollback percentage, so that we can see, for example, which one are the services that are having more rollbacks and which are the teams that are having more rollbacks, in order to try to understand where we can put our focus, our efforts to improve it. Now that I explained a little bit how we try to think about testing strategy, define a testing strategy, what is the testing strategy for TransferWise? The first point that I want to talk about is the intra-service testing. So the intra-service testing is that test that only requires your service and you can run your continuous integration environment. And I could be talking here about many points about the intra-service test, but I want to focus on 4 of them. Rethinking test pyramid, few mocks, contract guarantees, and loosely coupled. If we get straight into the test pyramid, any one of us that have been working with software development for more than maybe 5 years, you probably have faced the test pyramid. And you probably have been trying to keep this shape, and you know how hard it is. Most often than not, we end up in a shape that doesn't really resemble a pyramid. But why it was so important for us to keep this shape was because the unit tests, they run much faster than the other type of tests. And in a monolithic application, you have a huge code base, so you have many tests to run. And because of that, if you don't pay attention to the shape of this pyramid, you end up with your continuous integration environment taking hours to run. But we are not in a monolithic architecture anymore. Services in a microservice, they're supposed to be small. So if they are small, even though they might take long to run, you don't have that many tests to run. So what we've been seeing is that more and more teams at TransferWise, what they're trying to do is that they're trying to put less focus on the shape of the pyramid and more focus on the confidence that it brings. And something is important is as you go upwards in the pyramid, you have more confidence. And because of that, we believe that each one of the service, they should try to find what is the best shape for their pyramid. If it's actually the shape is a pyramid, go for it. But if it's actually a diamond or even a cone, that's still totally fine, as long as the overall time that you run your build does not take maybe 10 or 15 minutes to run. And another point that is quite important when talking about the test pyramid is related with mocks. So imagine this test, for example. You have a test that tests in a class, one specific method of this class, and this is the method is calling then the class B that has a chain of calls. By default, this test would not be a unit test. But in our obsession to have everything as a unit test, what is very common to see people doing is that they end up creating a mock for the class B because they want then this test to become a unit test, which we can even argue if that's still if it's a unit test when you do this mock. Regardless, what is important here is that once you do this mock, you are actually reducing the confidence because you're not using the re-implementation anymore. And another example where we are sometimes obsessed with mocks, when we're talking about external dependencies like Kafka or a database. It's quite common for us to try to mock those things, while in reality, nowadays we have Docker, right? So how long does it take actually to bring a Kafka container up? It's a matter of few seconds. So why not use the real implementation if we can? Well, if I'm saying that we try to avoid mocks, we should try to have as few as possible. Is there any situation where it makes sense to have mocks? The way that I try to frame this problem is that we should try to use the real implementation as much as possible, and only mock what is external to our service, and we cannot use a container. For in the case that we have a test that is testing a class in the service A, and then actually calls the service B, and then the service B calls C, and maybe even longer chain. In this case, you cannot really try to run Docker containers because maybe there are like a lot of dependencies downwards. So in this case, it might make sense for you to actually mock the service B. But when you do, we need to be careful with what we're doing, because a mock is basically an assumption. When you have a mock, you're basically saying that you assuming that's how the service is going to behave in production. And even more than that, you're not just saying how it's going to behave now, but you're also saying how it's going to behave in the future. So we need to have some sort of contract guarantees in order to make sure that it will keep working. When I think about contract guarantees, well, I try to think about two different categories. The first is the schema. So let's suppose then that service A is making a call to service B to create a transfer. And in the payload, you have a field called source, and it's like has a value which is a string. And in the response, you have an ID represented by integer. And what these things are, they're schemas, right? And at TransferWise, we are lucky enough to have most of our services running on JVM. And because of that, most of the service they have been doing at TransferWise is that they've been providing a client. So the service B provides a client that the service A puts inside of its service. And this client already has a contract there, because you're going to have the interfaces that the service B is giving to you. So for the contract guarantees from the schema perspective, that's how we've been doing TransferWise, and it's been quite useful. Now, if we go another step and we think from the perspective of the semantic guarantee, then things getting a little bit more complex. Suppose that you want to write a test that is asserting that when the source is a currency that does not exist, it actually sends you an error message. That goes beyond the schema. That goes talking more about the semantics. When you get into these situations, then what we believe is that one solution could be consumer-driven contract testing. And we do have some of them at TransferWise, but to be honest, we only have them in some bounded context. So for example, some teams that they are owners of one specific domain, within the service that they own in that domain, they have some contract testing, but it's not something mandatory for all their services at TransferWise. And the reasoning behind is that we've seen that the schemas guarantees that we have, as I presented to you guys, have been actually able to catch most of the issues. It's possible that in the future we are going to go with something to try to verify the semantics as well. But for now, we believe that the cost benefit actually is not paying off for our specific scenario. So I've been talking a lot about the inter-service tests. Well, one thing that is very important for us to have in mind is that as less coupled is our services, higher is going to be our confidence from the inter-service tests. So basically, what I'm trying to say is that if you have a very good, high-quality inter-service test, but even with that, you're not actually confident of deploying to production a change, it might be the case that actually this service is too coupled with others. And then in this case, I think it makes sense for us to rethink about the design of our system. Now, even if we have a very good inter-service test, even if our design is loosely coupled, even so, I think it's fair to ask the question, can we catch all the bugs before they reach production? And I don't have to see you now to know that the answer. You're saying no, it's not possible. Now, the question that follows that is, are we comfortable with that? Are we comfortable with this fact that we won't catch all the bugs before they reach production? And if we're not comfortable, we need to start thinking, what do I need to do in order to be comfortable with this fact? And I believe that although there are like many things that we can do, we already mentioned about having high quality inter-service tests, and there are some other things that we can do, but we should probably start from the fact that not all the bugs, they are equally scary, or at least they should not be equally scary. To give some context, for example, in August, at TransferWise, we did 2,400 releases. And most of them, they went pretty well. But in total, we had 42 incidents that happened in August. And then here you can see that we broke them down into severities. So that severity 1 is the most severe type of incidents that we have. And don't get me wrong, we are going to try to reduce the number of incidents as much as we can, but we will end up always having them. What we also want to do is that we want to have more incidents that are not as severe. And for that, I think it's very important, the next topic that I have in our agenda, which is testing in production. And that's a huge topic, and we could have a whole presentation only for that, but I'll be talking about some of the points that I believe that are worth mentioning about the way that we've been using that in TransferWise. The first one is, I couldn't stress enough how monitoring and observability is important. And I want to bring 3 points that have been particularly important for us in this journey. The first one is out-of-the-box dashboards and alerts. So when you create a new service, you get them for free. So that's pretty important. You don't even have to think. Another point is to create business metrics as well and alerts on them. When I say business metrics, what I mean here is that you should have alerts. For example, if the number of transfers that you created in the past 1 minute goes below a threshold. It won't tell you what is the problem, but it will tell you there is something wrong. Another thing that has been quite useful for us is distributed tracing, for which we've been using Jaeger. Another point on testing production is feature toggles, and we have extensive usage. I know that you know what a feature toggle is. You've probably been using them. What I think that is being a lesson for us is to have extensive usage of them. And also not only on and off, this feature is on, this feature is off, but also being able to configure, for example, I want this feature to be enabled only for myself, and then only for my team, only for the TransferWisers, and then maybe for a small set of customers, so on and so forth. And another point, pretty important, is smoke tests. So we've talked previously about cross-service tests. And when we talked about cross-service tests, what we said is that it's pretty hard to have an environment where we have all the services running fine. But we do have an environment where all the services are running fine. It's production. It has to be running fine. And that's where we've been running our cross-service tests. And what these smoke tests they do is that they run every minute. Maybe in the future they will run more often than that. And what they try to do is that they try to test a user journey. For example, creating a transfer. It goes through the steps to create a transfer. And if you combine some of these things we've been talking about, what we would get eventually is an automated canary release. And here we still have some things to improve at TransferWise. We do have some sort of canary release, but it's not fully automated, as I'm describing here. So we are in a journey. And what we imagine as the canary release for the future of TransferWise is that you have your customers. They are accessing your production environment where you have a service and need the service in the V1 of this service. Once you deploy the V2 of this service, it should not be available for our customers because you don't know, you're still not confident that it's working in production. So then your smoke test should be the only one actually accessing that service, that new version. And once it sees that it's actually working, then there is a high chance that it's going to actually work for our customers. So then you start enabling for 1%, 5%, keep monitoring, seeing that this new version is actually working fine, and then eventually it's going to get to 100%. And we believe that as better we get in the areas previously mentioned, less we feel the need to have an integrated pre-production environment. But the reality is that at TransferWise, we still do need an integrated pre-production environment sometimes. And the reason why that's the case is I've talked about being very good on intra-service tests and also being very good on testing in production using things like feature toggles. But in TransferWise case, we're a financial company. And that means that we don't have all the freedom that we'd like to have in order to test in production. So although you could test some things in production, you cannot pretend that you are a Brazilian, for example, in case you are not. So because of these kind of things, we still need sometimes a pre-production environment to help to make us productive. And that's where comes the last of the points in this presentation, the on-demand production-like environment. Why on-demand? It's because we already talked about the fact that a stage environment, this enterprise-wide test environment, does doesn't look like a good idea because you're not isolating yourself from the other people or the other engineers. But what if I could have my own staging? And that's where comes the solution that we created. We have the solution working for around a year and a half. And what the solution provides is that anyone inside TransferWise, regardless if an engineer or not, but most of the engineers that use this feature for sure, is that you can create an environment only for you. And once you create this environment only for you, you can do whatever you want there. You can deploy the versions that you want. You can bring down services to see how the system behaves, for example, and you are not impacting others in the company. Now, this kind of tool is not very simple to create. It's a quite complex tool. And while creating this tool, we had a couple of principles in mind. The first principle that we had in mind is that it has to be convenient. Otherwise, people wouldn't be using the tool. And for that, we created a Slack bot. So when you want to create an environment, what you do, you go there and you type create in the name of the environment, in this case, create Andre, and then it's going to, at the end of the process, you're going to have an environment only for you. And this environment that it creates, what you want is that you want it to be as production-like as possible. So things like we want the same versions as in productions, we want the same tools that we have in production, we want the same values of feature toggles that we have, and so on and so forth. But although we want this to be production-like, we also want it to be fast to create. Nowadays, we create an environment in between 5 and 8 minutes to create an environment. But it's important to have in mind that there is some compromise that we need to make between production-like and speed. A good example is databases. In production, we have one instance of the database per service. However, when you're talking about this on-demand environment, what we do is that we have one instance and we split this instance using schemas. Why? Because it's much, much faster for you to create a new schema than for you to create a whole new instance of a database. We also want this environment to be reliable. And don't get me wrong, this solution requires high maintenance. So the engineer experience team, we are the first line of defense when something goes wrong. And then, of course, we proxy to the service owners in case they did something that broke this environment. But also, we have monitoring tools that it keeps constantly creating environment and checking if it's run some smoke tests on these environments and check that they are working fine. And if they are not working fine, then you try to understand, the tools is smart enough to understand what is the problem, like it's one specific service that is causing the problem, so then it does not allow this new version to be propagated to the engineers. So when you do the create command, you're getting the versions which were actually tested and it is guaranteed to be working. Another point that we've been trying to put some effort in is to make this tool not very expensive. A couple of things that we did in order to make it not very expensive is that, first of all, it's ephemeral. This environment lives for 4 hours by default. You can increase, but it still is going to be ephemeral. And when you create this environment, you don't have all the servers that you have in TransferWise. You don't have the 350 servers that you have there. You only have the ones required for you to do a GBP to Euro transfer. But what if I want to do something different than that? If you want to do something different than that, then we have templates. And then you can use this template by running the command as create environment from and the name of the template. In this case, I'm using cards in case I want to test something specific to cards. So it's going to bring the services and the test data related with cards domain. And we try to create this tool having a product mindset. So we ask our customers, or meaning our engineers, how much they like the tool and what are the things that they would like us to improve. We ask, for example, how likely would you recommend this tool to a TransferWise engineer? And you can see here that in general, people are pretty happy with the tool, but don't let me fool you. This is far from perfect, but still useful. And another point that is quite important here is that we created this tool with the design and with the idea to use it only for exploratory testing. We don't think that you should have your service using this tool. Your service, the continuous integration environment of your service. Why not? Because if you end up using an integrated environment, you will end up coupling the release of your service with other service, and that's what we're trying to avoid. So I'm almost running out of time, so I'll do a quick summary of the message that I've been trying to convey. We need to be careful about staging environments, enterprise-wide testing environments, when we're talking about a microservice architecture. The key for us to be able to be confident without this enterprise-wide test environment relies on intra-service tests and testing production. What happens that at TransferWise, sometimes, and we see that less and less, we are having this need, but we still need sometimes, we need a integrated environment to perform some exploratory testing, and for that we ended up creating an on-demand integrated environment. So that's all that I had to show to you guys. Thank you very much, and I'll be very happy to answer any questions. So feel free to hit me on Twitter or even send me an email. Thank you very much.
Oh, I realized I was on mute. Sorry. So, Andre, thank you for the presentation. It was awesome. I think we will have a time for one or two questions, and questions. And I think the first one comes from Jakub. But isn't mocking about making sure that we are testing only one component and only its logic, not more? Would it increase confidence about this specific component?
Yes, exactly. I think that's exactly the idea. So what we try to do is that if we increase, the way that I'm trying to frame that is, if we increase the confidence of each one of the components, each one of the services that we have, in the end, we're going to have a system that we have more confidence overall. But that alone is not enough. That's why we need a very good testing in production strategy as well, like smoke tests and so on and so forth.
Mm-hmm. Okay. I will put out another one from Daniel. What type of testing do you perform before the real production or on the production, and not to block continuous deployment?
Not to test on different versions of the code. What types of tests do you perform before the real production or on the production? Yes. So before going to production, what types of tests that we perform is only the intra-service tests, the ones that you can perform only using your service, right? So you can do any kind of test there that you need, or you can even use some implementations like Kafka and your database and so on and so forth, but only in intra-service. And then when you go to production, then we have the smoke tests. The smoke tests are doing the cross-service tests. Now, it's going to depend on your need, of course. Imagine that you're deploying something that you know that can have some impact on your performance, the performance of your service. So then before that, you're going to probably run some tests in isolation for that service to make sure that it's going to work fine. And also when you go to production, you're going to do in a canary release way, so that even though you can then monitor and check if your performance is working accordingly. So it's going to, what I think that my question here is like, it's going to depend on the type of change that you're making.
Mm-hmm. Okay. Andre, thanks a lot. Thank you again for being with us. Thanks for an amazing presentation. And if you could stay a couple of minutes to answer questions on the chat on the YouTube stream, we will be very grateful. Thank you very much.
Thank you.
And right now I will hand over my voice to Jakub.
Hello.
To announce the next presenter.
Hi. I have a privilege and to announce next speaker. And Anya, welcome to Agile and Afternoon, Agile and Automation Afternoons. Hello.
Hello. Nice to see you.
Anna Radzikowska is currently working as a product manager of a Kanban maturity model. She's experienced in finance, training, and project management. What is really interesting is that she's a Kaizen culture and Kanban method passionate, but also an, I assume, passionate role-playing games player. And her role today will be to talk about eating, especially eating elephants and evolving. And that sounds pretty interesting, I would say. So, ladies and gentlemen, Anya, stage is yours.
Thank you very much, Kuba. And before I even start, I would like to say big thank you to organizers of Agile and Automation Afternoons. I was very eager to attend Agile Automation Days. This year I was there last year and it was a great experience. It will stay with me for a long time. And to be honest, I couldn't wait to also go this year to Poznań and see you all guys again. But we have what we have. So once again, big thank you to everyone who were able to organize this Agile and Automation Afternoons. And I really hope that next year we'll be able to see face-to-face finally, like we did last year in Gdańsk. So see you there. But today, thank you very much to everyone who decided to spend this evening with me. My name is Anya, and I will be telling you today about humans and emotions. Because I know that yesterday and even still today you will have a chance to hear a lot of great technical talks. So you will have a short break with me from the technical talks. We'll be talking about emotions and reactions. And before we start, just a few more words. Who am I and why am I talking even about this? So first of all, I'm a storyteller. And not only by education, because, I have graduated history at the Agile University. It was very, very long time ago. And I was taught how to teach children. So to teach children, you really need to be a storyteller. But also, as Kuba mentioned, I play role-playing games, classical, paper, RPG, and I do it for 16 or 17 years already, sometimes as player, sometimes as game master. So again, storytelling is part of my life and a crucial skill I need to have. I'm also Kanban enthusiast and people devotee, and these both things go together because I always say, if you do Kanban, you need to love people, otherwise it simply doesn't work. And I believe that people are the most incredible and the most fantastic creatures in all over the world, and that's why I'm very happy to be here with you, and hopefully we'll have a chance to answer some of your questions. And what I'm going to tell you about today, it will be about change. It will be about the change management, but to illustrate you this whole concept of change, and before I even go to the theory of change in our brains, a few words about my personal change management and the way I went through the last 2 years. So maybe you remember the Hobbit movie and the scene when Bilbo Baggins is running through the fields screaming, "I'm going on an adventure." So it was me and my husband 2 years ago when we decided to take an adventure and buy a house. And we thought it would be good for us and for our small child to move from small flat to the house nearby Krakow. And that day, it was the beginning of a huge adventure for us. And it may also happen to you that when you start any change in your life, smaller or bigger, at work, outside of work, you may see it as kind of an adventure that you need to take. And maybe someone told you one day that, at the end of this adventure, you will see this and these benefits. But until you go there, you need to take yourself, of course, also your organization, your team, but first of all, yourself, through this whole process of change. And for me, it was the journey and adventure, not only for me, but also for my whole family. And not only building a house, but something even worse from my personal perspective, which is removal. I honestly and genuinely hate removals. And when I was thinking about moving all of this stuff from our small apartment where we collected these things for 14 years and pack everything, then move it to the house, then unpack it again, I was sick, literally, emotionally and physically. I was thinking about it. And I knew that I have to do something with this emotion to be able to cope with it, because no one could do it for me. So this whole story of building house and removal was this huge elephant that appeared in my life and started to crush the pieces of glass of my perfect life. And probably you know the answer to this question, how to eat an elephant, because this is not my question. But before we go to that, I would like to tell you shortly about some theories behind how people's brain operate. And we'll start with Professor Daniel Kahneman. Professor Kahneman is Nobel Prize winner in economy, but actually he is a psychologist. And for his whole life, he was studying human brains and how people behave, how people react to certain situations. And in one of his recent books, it was 2010, when he published this book, Thinking Fast and Slow, he described two systems that we have in our brain. Of course, this is simplification, but it was also the way how he visualized this concept. So we have system one, which is fast in terms of reactions. So reactions, emotions, these are the words associated with system one in our brain. And we have also system two, which is very slow because it takes information from our knowledge base. It takes information that we associate by learning and we acquired by learning. And system two, answering to the situations that happen to our life by system two is very slow because it first needs to analyze different situations and only then it can answer, whilst system one answers immediately, and this is based on the reactions. And to give you an example of how these two systems differ, I will give you another example from my life. And again, 2 years ago. So this 2 years ago was pretty difficult year in my life from change perspective, because I decided to finally learn how to drive a car. So for all of this time living in Krakow, I actually didn't have to drive a car because everything was very close and it wasn't necessary for me. But when we already knew that we need to move nearby Krakow, but still this is a village, and my work and my child kindergarten probably will be in Krakow, I decided I need to learn how to drive a car. So I took driving lessons. It was something very new for me because by then I didn't even know how to switch on the car. So I took the theoretical driving lessons and then I started to learn how to really drive a car. So I'm not sure if you had similar experience, but the first moment when I stepped inside the car, I was very stressed. I didn't know what to do, how to turn left, how to turn right. I had to remember about all of these things, buttons I need to push, and about the teacher next to me, and even more about everything that's happening around me. So people, other cars, trams, buses. There was so many elements that I need to remember, which I was not yet able to react to. So this was the moment when in my life I operated on the level of system two. So everything I have learned, my system two started to analyze. So before I turned left, I had to analyze what I need to do to turn left. And it took time. But then after this 30, 40 hours of learning how to drive a car, then finally passing getting my driving license and another lessons, because these were still lessons without the teacher, but I was still learning how to drive a car by myself then. This was a process when my system two, which analyzed the situation that's happening on the road, taught system one how to react. And right now, after these 2 years, every day driving the car, most of the things I'm doing happens on the system one level. So I operate on the reactions level. I don't need to actively think what I need to do to turn left or right. I just do it. And at the same time, I can listen to radio, I can talk to my husband, which was unimaginable for me at the beginning. So you could think, why do we really need system one if we could analyze everything based on system two and we could live in our perfect logic world? Actually, system one is something what Mother Nature left in the process of evolution for us. You can imagine that people at the beginning, our ancestors sitting in the bush, didn't have time to reanalyze, is the sound somewhere in the woods a lion that wants to eat me, or maybe we should discuss, or maybe we should proceed it further? No, our ancestor just get up and ran away, and it helped our species to survive. So this is what we still need, because even referring to our road situations, sometimes when accident is very close, we don't analyze should we avoid this accident or not. We just try to avoid the accident, and everything happens on the reactions and emotions level. So this is why we need system one, but also system one can be our enemy when it comes to situations like the change. And if you ever encounter a situation in your life that someone came to you and told you, so now we are going to reorganize our department, or we are going to create new jobs and new roles, and now you, dear project manager, will be called a Scrum Master, and you receive the whole list of benefits as a result of this change, your system too can say, okay, I understand it, yes, we'll have a lot of benefits and we'll be fine. But the same moment your system one says, oh no, I don't like it, I really like to be project manager, or I really like to be Scrum Master, don't change anything in my life. So again, it takes time for system one to learn and to be taught by system two how to operate in the new environment. And what we see as a traditional model of change management was described in 1920s by McKinsey. And this is the model that you can see here. So the traditional change model assumes that we have point A, the current process. And from this current process, we travel easily and straightforward to point B, which is the future process, which is in advance described and defined. But unfortunately, this is not so easy, and maybe some of you already experienced it, because the change process looks rather like J curve. So what you can see is like a huge J letter reversed, and this is what we use in our Kanban words to really describe how the change process looks. So, okay, you start at some A point, so some current process, but then eventually at some point of time you come to the moment when you experience a drop in the change process, and it can be a drop in motivation, it can be a drop in the engagement, sometimes even the business outcomes of your organization. And the deeper you go in this hole in the J curve, the less safety you keep for yourself in this whole process. So on vertical line, we have our capability and we have our safety level. And what you can see on the horizontal line is the time. And this time also is referred to the patience of your patients, your company, your managers, your colleagues. So the longer it takes for you to stay in this hole at the bottom, the more difficult it may be for you to get out of this hole and start to see the benefits of the change. And if you operate in the lower maturity organization, it may be the moment when the managers, especially the ones responsible for the budget, may feel that this change agent or agile coach maybe are not so great as we thought when we hired them, so they should be fired, and we hire another change manager and another agile coach, which is actually not their fault that it happened the way. It's rather the fault of the process and the system that was introduced to go through to take organization through the change process. So how we can do it better. You can look at this green line. So what we suggest for you to do, not design your change as one huge step from A to B, or one huge elephant, if you want to stick to this metaphor. Rather try to eat your elephant piece by piece. So do small steps, and because this way, on one hand, you don't drop very deep in your safety level, and on the second hand, horizontally, you don't require so much patience to take you and the organization through these small changes. And how does it work? So again, we are in the initial process, so there is no change to McKinsey model from last century. And from this initial process, we take one small step. And when we take this one small step, we observe what's happening, how our organization, our team, our department, how we react to the change. We evaluate fitness of the change to all of these levels of our organization. And if this change is good, we take the next step. And again, we evaluate the change. Then we take the next step, and again, we evaluate the change. And we do the small steps also to introduce, after each step, a very quick and short feedback loop, which will provide us with information that we can use for further improvement. So it may happen that even if we designed our change process to go one direction, it may happen that we need to change the path because we see it from the feedback that we received from the environment, that this is not the good direction. We need to find another way. But it also may happen that when we evaluate fitness, we see that the change wasn't good for us and we need to roll back. And again, because the change was very small, it's easy to roll back. Sometimes the change is so small that no one even noticed that you did it. So there is no resistance from the organization and from people around you to roll back the small change because it doesn't hurt so much. And again, you evaluate fitness. If it's okay, you move forward. And you evaluate fitness and so on and so forth. And the future process is not designed, but it's emergent. So we achieve this process by assessing the change all the time and gathering feedback all the time. And this is how we should approach the change as the process which is evolving and not going strictly straightforward line from A to B, when we don't know if B is actually the point where we want to be. And how did it work for me? So what you can see here is actually my house and plan for my house. So when I started to think about it, as I said, it was a very, very huge elephant, which I couldn't even think about as a whole. Because what I knew was that I want a house and I want it to be pretty, which you can imagine are pretty shallow requirements. So what I did, because it wasn't yet ready, I made kind of a virtual trip through it. So I closed my eyes and I went through a virtual door and I saw, okay, here I have my room and I have a kitchen. Then I go upstairs, room 1, 2, 3, 4, and the bathroom. So this was the first step to really divide our elephant, our huge change, and my house into smaller pieces. Smaller, maybe less complex, because size is not necessarily the one we are looking for. So I made this house less complex, and dividing it into rooms was already decreasing the complexity. So then I started to think from the room's perspective. So let's think about the kitchen. Is kitchen complexity small enough for me, or I need to decrease it further? So yes, I had to decrease it further because my kitchen consists of furniture, I don't know, cups, cutlery, maybe some curtains. And what I started to do, I started to put all of these elements on the board. So what you can see here, you may associate to the Kanban board, which is this is kind of the Kanban board, but it has nothing to do with Kanban systems, to be clear. But this is completely another story. So what I tried to achieve was to put everything what I had in my head somewhere externally. And I also used the color coding, and I divided my house into the smaller, the least complex possible pieces. Looking from a work perspective, you can think about it as the least complex possible tasks. And this kind of approach has some significant benefits. I will just tell you about two of them, which were the most important for me at that moment. The first one I already mentioned. So I cleaned up my brain from thinking about this. And this is what I would like to encourage you to do. You have beautiful brains, you have smart brains. Don't overload them with such a mess that you just need to remember about. Use external tools, use Excel file, I know, PowerPoint, notes, use any tools like Trello, Kanban Flow, anything what you have for free, and you can easily use to clean up your brain and make space for thinking about something more important or more creative. Let the tools keep these annoying tasks for you. So create this external memory. So this is what I did, and it gave me a huge relief that even if I forget about something, I have it somewhere externally. So I didn't feel this pressure of remembering about all of this stuff. On the other hand, because I didn't work alone, this visualization helped me and my husband to work together on the tasks we need to go through. And because I also use some descriptions, some color coding, as I mentioned, we could easily assign ourselves to this work. So if he saw that, I don't know, right now I'm taking care for buying curtains to the kitchen, he knew that he doesn't need to think about it. So it was my task. And it also served for the cooperation. So we didn't, of course, we talked to each other, but we didn't have to talk all the time to each other. When I was at work, he could easily check what we are doing and where we are with our process. And this is also, it can be also useful for you. Because I assume that you are not lonely islands and you have people around you, even if sometimes you have specialist role and you don't have a team, you normally cooperate with the other people. So to make the work transparent, to make work visible, and to enhance this cooperation, it's good to make all of these things available for everyone. What's in it for me, you may ask? So again, if I would like you to take one or two small pieces from this presentation that you can start to implement next Monday, because this is our goal. Maybe not next Monday, maybe even tomorrow. The things I would like to ask you for is apply small evolutionary change in your life. So don't try to bite the change at once. Eat your elephant one piece at a time. Take small steps and apply this approach not only at work, but also apply this approach at your life to anything what requires from you an effort and change. And the other small piece, try to use external sources, external tools. If you don't do it yet, don't overburden yourself, don't overwhelm yourself with remembering about stuff that can be just put somewhere outside. And last but not least, remember about people and values. Because, as I mentioned, we do not operate as lonely islands. So I would like to encourage collaboration and agreement so that everyone knows what we do and why we do it this way. And last but not least, respect. Respect for everyone as human beings and respect for who we are, what is our experience, what we can bring to others people's life. Good luck with your change. Thank you very much for your time. And now it's the questions time.
And we are quite on schedule. We have like 10 minutes, so I can ask some questions. Currently, we have 3, and I will start with my own because I know it the best. So basically, if we are in the middle of a change and we're chewing too large a bit. So the long change, this long, wrong J-shaped process that you described in the beginning. Do you know a way how to persuade the manager not to cut it in the middle, and just let it rise?
First of all, I will give you the answer that is probably the favorite answer of Agile coaches and auditors. It depends. But to give you some examples, I say it depends because it depends on your manager and on the needs of your manager. And I always start with needs and trying to understand what's the goal of the other person. So say, maybe I will just give you example. I had a manager who was concerned about the budget. So when we did a project, she was a budget owner, so everything had to be within the budget because we were not able to get additional funding for this project. And to support her decision making, she wanted from us a lot of reports and a lot of statistics. But actually her need was to keep the things in schedule and in budget. And when I think about her and her needs, if when we were, because it was also kind of traditional McKinsey change, so we were in the middle of huge drop in our efficiency from the project perspective and also from the business perspective, and actually we couldn't turn back, but also we couldn't move forward. So what we started to do, we collected data, because when you have information and when you have data, you start to build a history of what you have done, and also based on the data, you can start to predict the future. So we are not estimating based on the gut feelings and what we think may be useful, but we really start to forecast the future based on data. And for her, it was very helpful because she was operating on this level of information. She needed data, she needed numbers, and she needed a precise forecast for future. And it also gave her kind of an assurance that we know what we do, even if the whole situation seems to stuck for a moment and we don't know how to move further. You also may have different kind of people who don't take care about data, but they are just micromanagers and they want to manage the time of everyone. So again, it's good to look at the people's needs. I would start from this, and then try to adjust your actions to to the way how they operate and the way how they think. And I don't know who asked this question, but if you have any specific example, I am really happy to talk about it offline.
No, that was mine question. That's really mine question. So yeah, I can give you examples later on.
Yeah.
But let's go to Michal's question. What in case of another change coming in when we still did not finish implementing the last one? How to approach it?
Oh gosh, this is my favorite question, but probably would need another few hours to answer it.
And by the way,
Yes.
I kind of feel that it is connected to the next question that showed up, which is how not to be in a situation of everlasting change process in step-by-step process of change. And I mean, you can approach them together.
Yeah, so first of all, when I said that we take it step by step, I don't mean that we throw away the McKinsey idea that we want to reach point B ultimately. So we always should have a goal in our mind. So why we really do it? Is it, do we need to improve our system? Do we have any requests from the customer side? So we should have this final goal in our heads, but the difference is how we achieve this goal. So it all depends how you are constrained in terms of time and how you really operate in your process. Do you have any fixed date when you need to deliver your work, or you have to just deliver the work and you don't operate within the fixed dates, but rather within SLAs. So it all depends on your process and or your organization. So I wouldn't say that we stuck in everlasting change process. I would rather think about how to achieve the goal based on do we have SLAs or we have fixed date for this goal, and try to achieve this goal, but again looking at the data, because I had 2 years project planned, and I had a budget for this project, and I knew what I should achieve at the end of this project. But how we do it was on us, actually. So I knew that I cannot treat what I'm doing as everlasting process. I need to achieve something in 2 years' time. But to be able to achieve it, I started to look at historical data. And if you don't have your own historical data, start to look at the data from any similar project or process. If you don't have any similar project or process, the next step is to just assume something and then start introduce the change in a small steps to be able to gather feedback and be able to adjust your assumptions to the current situation. So that's why I'm talking about short feedback loops, and that's why I'm talking about small steps, because having small steps, you have data that helps you to adjust yourself to be able to reach this point. And of course, at some point of time, you may realize that maybe the goal was over-optimistic or you are not able to achieve it. But then when you have a data, you can also use this data to talk to your stakeholders, to talk to your customers, to show them what you are able to achieve. And you tell it to them in the process, not at the end of the process, when after 2 years you know that you are not able to deliver anything to them. And Kuba, can you go back to the previous question?
Exactly.
What in case another change comes in when we still did not finish implementing? So this is a question about balancing demand and capability. So another change is demand from our customer, no matter who this customer is. It can be internal customer, so someone from our company that wants something from us. It can be external customer, so we get another financial engagement. And on the other hand, we need to look at our capability and our capacity too. So how we are able to meet this demand. If we are already occupied by the current change process and we see from the capability analysis that we are not able to meet this demand, this is a question to decision makers. So now we look from the benefits perspective. What is more beneficial for us? To stop current process, project, building current products. And again, we have different scenarios here. So we can discard this project, or you can shelve this project. So it may happen that it's more beneficial to wait with current project for another time and another opportunity, and it makes more sense to start another project in the meantime. Or maybe this new opportunity is not so beneficial as we thought. But again, to be able to take this decision, we again need data, because without data, you will not be able to talk to the ones who comes to you with demand that you are or you are not able to meet this demand.
Okay. No more questions now. If you guys have any more, please ask them in the comments. And Anya promised to have a look there.
Yes.
In YouTube. And Anya, thank you very much.
One more thing, I almost forgot. Every time after live sessions, but also now after online sessions, I invite everyone for a coffee. So if you are somewhere in Krakow or nearby Krakow, I invite you for a coffee if you want to talk to me about Kanban, but not only about everything what's related to change and process management or product building. We can also engage in online coffee. So I'm open for discussion, and just ping me over LinkedIn, I think is the best option, and we can chat. So feel invited. Thank you very much. It was a great pleasure for me. See you.
Thank you for being here for us. great presentation. And now, ladies and gentlemen, this is the time that I hope you are not waiting for, but please grab a coffee and stay with us for one more session. Now it's break until 7 p.m. So see you then.
All right. So I think it's the time for our last presentation. Last but not least, I want to welcome Olga Maciaszek-Sharma. Hello, Olga.
Hello.
It's great to have you here on our virtual stage. Olga is a software engineer in Spring Cloud team at VMware and also a contributor to various open source projects. Before switching to development, she worked for more than 3 years as a quality assurance engineer specialized in test automation, which is a very unique combination of skills. And tonight, she will tell us how to build better APIs, faster tests, and more resilient systems with Spring Cloud Contract. The floor is yours, Olga.
Thank you, Ola. So let's go to the presentation. I will not talk a lot about myself because Ola has already introduced me. Just something to know is that I now mostly work on Spring Cloud Load Balancer, Spring Cloud Contract, and Spring Cloud OpenFane. And you can see my GitHub and my Twitter linked here. So what will we be trying to improve during this presentation and with the tools that we can use that we will talk about during this presentation? So I'm not going to pretend that I have a silver bullet or, as we say in Poland, a golden hammer that will solve all your problems. However, we will try to solve some of them. The first thing is we will try to make tests faster. So back a few years ago, back then everybody had monolithic applications, or at least most of us. And the monolith, what it has, and a characteristic that it has is that it can be tested at the highest level of abstraction. So we did that. We wrote end-to-end tests extensively. We created automated end-to-end tests, manual end-to-end tests, and they were extremely popular up until a few years ago. And we've got sort of used to the things that also came with end-to-end tests. So many of us got used to end-to-end tests repeatedly failing on environmental changes. And we have, like, I guess, quite a lot of us have probably seen deployment pipelines that will take 2 hours to execute all end-to-end tests and then fail at the last stage because there has been an environmental change that didn't have anything to do with the code. And I have seen it at least in 3 companies, I would say, really pipelines that took hours on end. And it was so prevalent an issue that the community has seen a need of adding a we need the beer plugin to the Jenkins pipeline. And even though, of course, what I'm saying is reflects the best practices, and it does not have to be this way. And there are ways to avoid a lot of these issues if we follow certain good practices while creating end-to-end tests. The point is that the end-to-end tests and things that are tested at this last level will always be most time-taking. And very often what happened in projects is we reached a pathway, we were on a pathway to the automation, as Venkat Subramanian calls the too much prevalent UI level verification. So why did we use them? As we've seen, the end-to-end tests can be very slow and unstable. They rely on collaborators. If we have any external database or a different app, there are a lot of things that we have to set up, but they are reliable. So we mostly trusted these tests as the tests simulated directly the actual user trigger processes, and we could feel that they were reliable, they simulated user behavior, they were comprehensive, and they verified borders. So even though they were slow, we felt very safe with them, or at least safer than just with having unit tests or stub tests. However, what happened then? A lot of us have moved to microservice architectures. And this is not to say that this is the optimal and the best architecture. However, in today's world, there are many use cases where this ends up being the most convenient architecture to solve a given problem. And as we move to the distributed architectures, we also had to learn not only how to develop the code differently and deploy it differently, but also how to test it differently. So we divided our code bases, and now we had these small teams working on small code bases to introduce features faster and do fix any bugs faster. And then, of course, we also want our tests to be fast. Also, we have managed to decouple the way that we develop our applications. So that is sometimes overlooked, but actually it's equally important, if not more. What we should have in order to have a reasonably working microservice environment is also decoupled deployment. So we need to be able to deploy our applications separately. And that also means that we cannot have a huge environment where we'll be deploying all the applications and managing versions of these applications and only testing with the end-to-end test and then deploying the versions of our applications that have to go together. So that would be deployment coupling. We don't want that. We want to be able to test and deploy any given service in our microservice ecosystem individually. And as we had now agile teams, we also wanted to have agile releases. We wanted to report the benefits of continuous deployments or even continuous delivery. So again, we needed faster tests. Another thing that happened is that our industry has realized that things will always fail. So there was this time where we thought that if we write very extensive documentation of any new feature, and we have a team of 5 analysts that discuss it, and they take half a year to write it, then we develop it for another half a year. And then we have 3 independent teams of testers that will run automated and manual end-to-end, all sorts of tests, and will take another 3 months. And then we will do a code freeze that will last 1 month. Then if we push it now to production, everything will work. So at some point, we have realized as an industry that that has never happened, that this approach and this principle that we believed in has been failing us altogether. And we realized, even with the monolith, that things will always fail. There will always be errors. And what we need to do instead is find a way to make it safe to fail. So we know that things will fail. We just want to be able to revert the changes and first of all, find the changes that cause the issues as fast as possible. So we need to have small deployments because only then we have a very small piece of like set of commits, let's say, that we need to go through to verify which one of them has caused the issue. Then we need to be able to create a fix very quickly, test it very quickly. And this is important to actually test it, not to just push some patches to production in some different way. No, because we can be introducing regression issues. So we want to test it fast, and then we want to be able to deploy it fast. And this becomes even more important as we move to microservices, because as Susan Fowler says in production ready microservices, in the microservice environment, if there is something that can potentially fail, it definitely will. So this is very important. We need to make it safe to fail. So as we had to adjust to all these changes and make our testing process much faster and much more stable to make our deployments faster and stable, what happened in the industry in general was a shift to the left. So we started moving our tests this way. So more unit tests, more integration tests, much less end-to-end tests than what we were used to before. So much less of this reliability at the same time. And for the integration testing, again, we wanted to avoid the lengthy network communication. So we started using stubs. And stubs are very popular. There are several frameworks that can for example, allow you to imitate an HTTP movement. There is Hoverfly and there is WireMock that I'm going to show you here. So with WireMock, it's sort of an in-memory HTTP server that will behave as you tell it to. So if you describe an interaction like the one I have in the slide, you're telling WireMock in this JSON that if I send you a request with a GET method and with a URL endpoint X, let's say, then I want to get from you a response with status 200. And that works extremely well. So WireMock is a great tool, and it will feed us all these stubs responses when we do the right request during our integration tests. So we write our stubs as the consumers, so the apps that consume somebody else's HTTP API. And then we test against these stubs. So what can go wrong? Everything works. We've written the stubs, we've written the test. It's awesome. What happens, however, a lot, and I've seen it a lot in production, it happens all the time, is when we only test it with stubs, when we ship it to production, things fail. And there is a very simple reason for that. So for example, in our scenario, the same team usually, or even the same person, creates this stubbed interaction, and from the consumer team, so the team that is running the integration test, pretending there is a different app that has an API, but instead having this WireMock server. So they sort of write this stub, which is a description of what they think the production server on the other side will return. And it does not have anything to do with what it actually returns. Because as in this example, for example, just the URL could be endpoint Y, and it will already fail in production. Because unfortunately, this is just wishful thinking. So this is how we want the production server to behave. This does not have anything to do or does not give us any guarantee that the production server actually behaves this way. And the same thing happens with messaging. So we can have sort of stubbed routes. Many frameworks provide tools to stub messaging routes for integration tests on the consumer side. But again, since we just describe how this stubbing should look like, and then we test against it, we are not aware many times that our production and the other side looks slightly different. For example, the topic is different. Or this is even more prevalent, the framework that we use, so the stubbing framework that we use and the testing framework that we use to verify our messaging interaction does not verify this realization and just uses the same POJO that we used for stubbing. And then what can happen is that actually in the server, they're expecting a product ID field, but we have an ID field. And then if we have only tested against stubs in our integration tests, and we didn't test it with end-to-end, when we go to production, things will fail. So to summarize, stubs are great for prototyping, but if we have stubs alone without contracts and we test against them, these tests and these stubs do not guarantee absolutely anything. So going back to this, contrary to end-to-end tests, stub tests are very fast, very stable, and independent. We do not need to set up anything in our environment. However, they're extremely unreliable. So that was a short description of the first problem that we want to try to solve. And when it comes to the second problem, better APIs, starting again with the monolith, before we didn't really have a lot of APIs. So we had a server with some limited clients. We had very limited APIs. And very often these APIs were public or external. So first of all, they would not really change, or they would only have a new version possibly. And then we didn't care that much about them. So yeah, of course, we sort of cared and we also gave our users documentation. But if some of you integrated with external APIs of some systems based on documentation, you will know that more often than not, the documentation no longer reflects the API. But people lived with that because there was no other way of doing that. This was a public API and it was difficult to collaborate. And we also had limited network communication for our internal apps. So there was much less of it. But then in a microservice scenario, network communication has become a first-class citizen. And now we have multiple instances of many services communicating with each other over the network. And we have a lot of APIs which are fast growing and even changing. So we wouldn't usually change a public API in the same version, but it does happen with internal APIs in companies. And then what we have is a possibility to collaborate between API producers and consumers. And that's a really good news. Before we go deeper into that, let's say what a producer is and what a consumer is. So for the purposes of this presentation, a producer is any app that either exposes a REST API or sends messages. And then consumer is an application that will send requests to that API or consume the messages. So going back to the collaboration between the producers and the consumers, I am guessing that at this point, probably many of us are asking yourself the question, why would we want to do that exactly? So if we are the producer team, then we own this app, we have built this API, we know this app best, and we also know how to build this API. But then, do we? So even though I guess that many of you that work with code have seen a lot of times code that seems to have been written with the idea in mind of this code was hard to write and it should be hard to read. And then at some points we turn on the blame feature and we see our own name, but that's a different story. So even though that does happen in practice, we still know that we actually should make our code in a way that is easy to read and not easy to write. Why? Because the code is usually written once, sometimes modified, but it is read a lot of times. So actually, readability is super important. And it is very similar with the API. So although the producer team usually has to create it, it is the consumer team that has to live with it later and use it all the time. So they really often know better what this API should look like to be practical and usable. And that's why it makes sense for the consumer to actually drive the creation of the API. And this is something that many of you might have seen in practice if you happen to create an app where you had to create some kind of a front end and a back end. And if you did it right, then you probably started with the front end and what requests it will be sending to the backend. But if you are mostly a backend engineer like me and you started with the backend and first created the API and then decided to add a front end layer, you usually would soon realize that if you started working from the other way around and thinking what request I want to make and what information I actually want to display, that would have been much easier. So that's why it's important to involve our consumers in the creation of our APIs if we have this possibility, if we work in the same company. However, the problem with human collaboration is that if there are no appropriate processes and safeguards in place, things tend to go wrong very easily. So now I would like to show you a potential answer to both of these problems, which is the consumer-driven contracts approach. So what is a contract? A contract is a set of codified rules that defines that if the consumer sends an input A, the producer should respond with an output B. And this can actually, the definitions of these inputs and outputs and of this interaction can look very similar to what we have seen before while looking at the WireMock stubs. However, there is a very important difference. So the big difference is that the contract has to actually be enforced or guaranteed for it to be a contract. And any contract testing frameworks will provide this capacity. So we will show this with the example of Spring Cloud contract shortly. But if you are using any other contract testing framework, this is also the main rule. So you need to guarantee that this is not wishful thinking anymore, that your producer app actually behaves the way that the contract describes its behavior. So that was a contract. And going back to consumer-driven contract, as we've said, it is an approach where it is the consumer that drives the creation of the contracts and the subsequent API changes. And of course, if you think you have some novel and great and new idea in the IT industry, when you deep digger, it appears that Martin Fowler has had that idea 20 years ago. So consumer-driven contracts is not a very new idea. However, it is still new in the industry because the implementations that allow you to do contract testing, so the contract testing tools are quite new. One of the possible implementations or tools that we can use to do contract testing is Spring Cloud Contract. And let's have a look at this sample producer consumer flow with Spring Cloud Contract, and we will also look at code examples. So first, the consumer will check out the producer code repo and work locally on a contract. Why the producer code repo? Because this is not obligatory, and we will see later on that this can be modified. However, in the most popular and base scenario, in Spring Cloud Contract, we suggest the contracts to be kept on the producer side, so with the producer code. So the consumer will work on them and will drive the creation of the contracts and the API, but we expect it to be done via pull request in a Git repository. So the consumer will check out the producer code repo and work locally on a contract. And we assume one thing. So we assume the producer repo has already the Spring Cloud Contract Verifier plugin set up. So if it doesn't have it, you will need to add it. And yes, it also has to be configured. So here we are using the test framework JUnit 5, but you could also use the older JUnit version. You could use Spock. We are also setting up test modes. So since this app is a Spring app that uses Webflux, we are setting web test client. We could also use mock MVC, or we could also use JAX-RS, and we could possibly also just run an explicit app and test against that. So, I mean, we have explicit mode, which will run the entire app, and you can test against that. And then we have specified base class for test, which is something that we will see later on. And now we create our contract. So in Spring Cloud Contract, you can create contracts in various ways. We provide a Groovy DSL, a Kotlin DSL, and also YAML. So this is the one written in Groovy. And similarly to the stubs that we've seen before, we want to send a request. So in this case, we will be sending a post at the URL fraud check. So we have an application that verifies if somebody that is applying for a loan or a credit card is a fraud or not. And then in the body, we will send a client ID. And here we don't want to pass the actual ID because this can change, obviously. So we only want to set any UID will be a correct amount, will be a correct field for us. And then we put the loan amount, in this case, the amount that we have provided here. And we can also put a bigger amount, and we will expect different results. So for example, here the amount is too high. If we put a smaller amount, we will expect to get an okay answer. That's just an example. And also we provide you a lot of these ways of working with regexes, with matchers, with values of some kind and not specific values. And then we're going to set headers, and in this case just content type, but obviously we could put more of them. And then in the response, if we get this kind of data, we are expecting to receive a status 200 and a body that says the person is a fraud and amount is too high, and then again some headers. And here we have exactly the same contract as a YAML. If you prefer YAML, that's completely fine. Only you need to see that we do have this regex matching by UUID, but it's in the matchers section. So we just put a sample UID and client ID, and then in the matchers we write that actually we are going to accept any UID based on regex, and the rest goes same. So our consumer has created this new contract. So what we are going to do is to create a pull request, and producer will review the contract PR. And now this is actually very important because sometimes people ask us, okay, so our consumers will just impose us what the API should look like. That's just not fine. And then we tell them, well, if you work with PRs, you're not expected to just accept all the PRs. What usually happens is in a pull request, there will be a discussion and things will be adjusted and changed, and there will be a place to discuss things and decide what the actual API should look at the end, how it should look at the end. So let's say we have already collaborated and both sides are fine with this contract, and the producer wants to implement the API in this way. So what the producer will do will run the build on the PR branch. And what should happen, what the Spring Cloud contract plugin will actually ensure that happens, is that this build will fail. Why? Because the producer does not yet have the implementation of that. So does not yet have an endpoint or any logic behind that endpoint that will provide a response to the request that the consumer sends. So what we can see here is a test that was automatically generated by the Spring Cloud Contract Verifier plugin. So this, you don't need to write these tests. They are generated automatically for you. And they verify exactly that, whether the contract is met. So whether if we send a request that matches the contract, we will get a response from our app that also matches the contract. So that's something we can ensure, and that's how using contract is going to be different from just using stubs. We are getting the certainty that things actually work this way in the producer app. So then the producer has to actually add the required endpoint and is going to run the build on the PR branch, and can then also merge the code and deploy. And as the producer runs the build, what will happen is that also a wiremux be generated. So we have already verified that our producer app behaves a certain way. So now we feel safe to actually provide a stub. It is a wiremux JSON stub as the one we've seen before, but just more complicated due to the regexes. So now, as we are sure that the producer behaves this way, we are going to create a stub, and then our consumers can use the stubs to run tests without our app running anywhere. Because now we are sure that actually this stub is not just a wishful thinking thing, it is the reflection of how our app works. So yeah, the code is deployed along with the generated stubs jar. So wherever you are deploying the application jar, say to an artifact repository, you would also deploy another jar just with stubs. And then stubs are used, stubs published by the producer are used by the consumer for integration tests. And let's see consumer build setup. So this is actually very easy to use. If you have a Spring Boot app, you just use a starter. in this case, Spring Cloud Starter Contract Stub Runner. And this allows you to easily set up the stubs for your test just using an annotation. So what we see here is the auto-configure stub runner annotation, and then you can provide the IDs of your stubs with the IV notation. So by default, they will match the group and artifact ID of your application jar with the stubs postfix, and you can also specify the port on which the stubs should be running. So if you create a request at that port and the request matches the contract request part, you will get the response from the stub. So now you can have fully separated integration tests with stubs that are not just some kind of prototyping thing, but really verify your consumer against a stub that actually reflects the producer's API. And of course, it's not a very good idea to have the port number just hard-coded in your test. So instead, you don't need to pass it, and you can use this stub runner port annotation to get the port. Also, if you don't like passing the IDs in an annotation, you can just use a properties file to set it. And if you are using, for example, JUnit, you can also use a rule. Also, you can use for JUnit 5, you can use an extension to get the URL at which the stubs are going and the port at which the stubs are going to be exposed. So let's have a look at the demo. What I'm going to do is I'm going to switch to the producer app first and share a different window. Okay, so this is an app that actually has this setup that we've discussed. It's very similar to what we have seen in the slides. So we have our plugin. Also, we have the dependency here. And then we have our router config. So here you could as well just have the mapping annotations and the get mapping and so on. However, since there are already many examples that we have published in the web with this approach and with the standard traditional REST API annotations in Spring, I'm adding this one, which has a router function, which is a newer functional approach that you can also use in Spring to sort of create your endpoints. So it will route any requests that come with a post at this URL and process them with the specified processor. So in the case of this processor, we are going to use the fraud detection service to verify our request. And when we have a look at the fraud detection service, I have commented out some of the code. So it should actually return values saying that our consumer is a fraud in some cases, but we are only now ever returning the response that the consumer is okay and is not a fraud. And as we see our contracts, we have two of them. So we have the one where we expect the client not to be a fraud, which should pass, but we also have a one that expects there to be a response of the endpoint given certain data saying that it is a fraud, and we do not have this implemented. So what we are going to do is we are just going to quickly run it and check what happens. So as you see, the tests fail. Also, you see that two tests were run, even though if you look at the test directory, we have not really added any tests. So let's see the test that failed. This is the test that, and these are the tests that have failed. And these are the tests that, as you can see, they're in the target directory. So they have been actually generated for us. We have not written them. And one more thing that I wanted to show here is the test base class. So that's something we have specified in the POM in the plugin setup. And yeah, it's here, as you can see. So if we go to this class allows us to do any setup necessary for our test. So for example, here we are using the rest assured web test client, and we are just running the controller or a router in this case in a standalone mode. However, we could be just running an entire application with certain profiles. We could be, if we are using Spring on a similar framework, we could be loading some certain configurations. Generally, it's good to load as little as we possibly need to run these tests and just mock or stub the underlying business logic, because what we want to verify in contract tests is going to be the functionality of the API. So actually the API syntax and not the underlying business logic that we will verify in tests on different levels. So let's just quickly fix it. And let's run it again. Okay, it has now passed and the tests were run and they passed. And what also happens is the stubs were actually installed. So we can see that a stubs jar was installed along our application jar in our local Maven repository. And of course, if we were running already a deployment pipeline, that would be installed in an artifact repository or wherever our actual production jar goes. But since we have it locally, we can now use it in our local consumer app. So I'm going to close this window and switch to a new one. So this is our consumer app. And as we have seen, the other application producer app is not running at all. And we have an integration test added here. So we are actually going to use a service that is going to expect that some communication happens to that fraud check producer app. However, we are not running it. So what we are going to rely on is the stubs provided by Stub Runner. And as I'm not going to use a remote artifact repository, I have installed it locally. I have set the stubs mode to local. I have set this port. But as we said, we can also do it differently without setting the port. And now we can run this test. And it should pass even though the other app is not running. Okay, let me go back to the main presentation now. So similarly, we can also create a messaging contract. And here we are putting a label that describes our contract, but this will also be used in the integration test to pick the right route stubbing. And then with messaging, we can have various scenarios. So for example, we can get a message and then respond with a different message, or just a message can be triggered by a method called, like in this case, or a message can trigger some kind of behavior in the system. So in this case, we are triggering with make successful payment. So this is the method that we'll call, and that we are expecting to trigger a message. We are setting where this message should be sent to. So in this case, payments, and we are also specifying the body and the headers that we want there to be in that message. And again, without our participation, a test is generated for us to verify that this really happens in our application. And when we do implement this and the test passes, then our stub routings can be used by the consumer apps. So the stub runner will provide a stub trigger interface that can be used to sort of trigger that message. So to simulate a scenario where we are getting that message to our underlying messaging test framework. And with messaging, we currently supports Spring Integration, Spring Cloud Stream, Apache Camel, Spring Cloud AMQP, Spring JMS, and Spring Kafka. So let's see a short demo of this. Let me switch the window. So here we have a payment app that is supposed to send messages, as you can see, to a different app, which is a shop app, and which will use these messages to process the purchases. So you can see the sending here, but as previously, we want to have contracts and we want to generate stopped behaviors so that we don't need to be running this app during the integration tests of the other apps. So here are our contracts. And if we run it, we are expecting to get stubs. And now let me change the window again. We will see our consumer app. So as you can see, this app is actually going to use this tap trigger to simulate that it is getting a message. And then we verify that a method that reacts to this message has processed the data in the right way. And I know this is going quite fast, so I'm going to also link the code of all these demos, and you can go through them slowly. And also, if you have any questions, then you can ask me, for example, in Gitter, and I will try to reply. Now let's go back to the main presentation. I'm going to switch to that window again. So there are some other features that we offer with Spring Cloud Contracts. So we can, for example, instead of keeping contracts with the producer, also keep them in a separate repository. And that is sometimes important, for example, for security reason when one team cannot possibly check out the code of another team. And then we also provide out-of-the-box Spring Cloud Netflix and Spring Cloud Load Balancer integration for the consumer tests. So if we have a load balance scenario, we will pretend that the stubs are just another app that is being found, and the calls are being directed to it through load balancing. And then also, if any one of you uses Spring REST docs, we enable creating REST docs from contracts and contracts from Spring REST docs. And then something that also many people ask about is the polyglot support. So this entire tool and framework is written in Java, and in Java applications, it just works. You can embed it into your code. But we also provide Docker images to contract test and then also to run stubs on the other side if you have apps written in virtually any other technology. So you can use our Docker images and still use the tools even though you don't use Java and you don't even have Java on your machine. It will work. And then something that also people ask about a lot, do we have support for Swagger? There is a community support for Swagger files where you can write the contract in a Swagger file that we do recommend you to use if you're interested in that. What implications do contracts have in our architectural decisions? So when we see this diagram of red-green refactor, I guess many of you know it. So as we start writing, working on a functionality, we can write a test. Since the functionality is not there, it will be red, it will not pass. Then we implement it, it becomes green. And then we want to improve this functionality, refactor it, and then again, we might get a red test and so on. So with Spring Cloud Contract, we are able to move this process, this red-green refactor approach on an architecture level where the teams collaborate together and start with a failing test from a new contract. Then let's say an endpoint is added and the tests are passing. And then another team wants to modify the contract. So creates a new PR, and then we go again with this cycle. Also, what we get practically for free while using contract testing is backwards compatibility checks in our deployment pipeline. So what we can do in the deployment pipeline when we have a new API version, provided that we want our API to be backwards compatible, and I guess usually we do want to have it, it's always better. I know some teams internally break APIs and just have this approach, but for me, even in an internal API, it's always good to keep it backwards compatible. So what you can do is test it with the new contracts, but then test it against the contracts that are currently your production contracts. Like this, you verify that it will still not break production apps, and then you can deploy. Does this mean that we can never do any changes? No, we can, but the approach that we would use here is similar to what we do, and we do not want to break compatibility in databases. So we would do a deferred update. So let's assume we had a field build time expressed in seconds. So our contract had a field build time and our application response had a field build time, and it was in seconds. Then we realized that that was actually a bad idea and we really wanted to have it in milliseconds. So what we would do, we would first only add the new fields to both the contract and the application. So our users will start seeing that now our producer app is also returning this field. And then they will start switching to it. And we will also enforce it because we will remove the old field, but only from the contract at first. So our consumers will see that the API is different and they have to adjust themselves. And then once everybody has had time to adjust, we can remove the old field also in production. And like this, we have transitioned from the old version to the new version without breaking the entire production. Some important things to keep in mind and lessons that I've learned along working with contracts, because before I was working on developing this tool, I've also have been just a user of it. So first of all, in order to avoid too much troubling maintenance, I suggest that you only test your API syntax and your API layer in the contract test and not the underlying business logic. The underlying business logic can be tested in your unit test. So we don't think that you should be now take, if you had all the end-to-end tests that were testing both the integrations and the logic, many teams would like to use contracts. It's a handy tool and do all this verification of the, again, integration and the logic. So many different scenarios with the contracts. But we do not really recommend this since that brings a lot of maintenance. So we recommend you test your API layer with contract tests and your business logic layer with lower level tests. Then if you're going to resign from a lot of your end-to-end tests, you might want to introduce other practices to make your systems more resilient. So definitely you will need monitoring, logging, and alerting. Then again, you might want to skip contracts for non-essential functionalities. So again, here, since we are shifting to the left, we definitely want to have way more contract tests than we would have end-to-end tests in this approach. However, if you have a functionality that nobody ever uses, gives you $1 a year, and if it breaks, nobody will even notice that, you might decide not to create a contract for that. So you cannot be extremely dogmatic. You want them to be more of them than end-to-end tests, but not necessarily every single endpoint. And then again, to avoid too much maintenance issues, you might skip multiple values. For example, again, you don't want to verify the business functionality, just your API. So you don't need to test for value A, value B, value C in the same field of your response. And I think the time is up. However, I'm going to leave you with all the resources. There is a project page. There are a lot of samples. So there's a repository with a crazy amount of samples in different scenarios. The docs can be found from the project page. And also I am linking all the code of the demos that have been shown, and also a blog post with a case study of using a contract and the link to our Gitter channel. Thank you very much.
Thank you, Olga. Thank you for this great and extremely useful presentation. I think we still have time for one question, but there is a huge and hot discussion on YouTube. So if you can, after the leaving us here, join us there on YouTube. Marcin already took part in this discussion with Daniel and Jakub, but I think you can support him there. But the question that was asked at the beginning of the presentation was just not to forget, can you shortly compare a Spring Cloud contract with Pact, or at least one thing for Spring contract, please?
Okay, so I don't really know Pact all that well. However, I do have a listing of differences and something I have written in Stack Overflow. So this contains much more information. But for now, what to me was important was the ease of use. So I think the contract, well, this is very subjective. And of course, I'm a committer of this project. So for me, the way of writing contracts in this kind of Groovy DSL or Kotlin DSL was much easier to use than what you do in Pact. But I will also link the response I've added in Stack Overflow once, listing more differences. So if you can have a look at that, that would be helpful.
Mm-hmm. So I hope Daniel heard you, and he will wait for your links on YouTube. So once again, thank you very much. It was great to have you here, and see you on YouTube.
It was awesome to be here. Thanks a lot, and thank you all that have participated. Thanks for watching. Thanks.
And muted Michał is back.
Cool. I think it's time to wrap up. I think it was thank you for everyone who attended the event. Thanks to everyone who joined the sessions and did listen to our presentations on our panels. I think without you, this wouldn't make sense at all. So thanks a lot, and also thank you to people who are watching that after the event. We've noticed quite significant amount of people watching the stream after the event. They shall be available for a couple of days for sure. So you can also have a look at day one, or if someone is interested to look through that, then it's still available. I will continue my thanks. Thank you very much to Jakub Rosiński. I think he dropped out for a while, but he really helped us with the organization and with making sure everything runs smoothly. It seems it did, right? We didn't.
We didn't have any big crashes, yes.
Yeah, so Kuba, thanks a lot. Thank you for your time invested into that, for participating in our preparation, with also for announcing our presenters, and also to take part in the experts panel. Thank you to our presenters. So Andrei, Anya, Olga, who joined us today. Also Nick, Mesut, Marcin, our presenters from yesterday, and our lovely experts. Ola, thank you.
Thank you, Michał.
There. Also Kasia and Rafał. Thank you for taking part in the experts panel. And one more person, Daria, could you show up? Don't be shy.
Always working behind the scene.
Yeah, I'm not sure if she will be here. So thanks to Daria Korneev. She did an amazing job in keeping us together, preparing all the content. Also to the designers, engineering, preparing the page. So thanks a lot for that. One I think more information when it comes to feedback. Please give us feedback in the stream and the YouTube stream. There is a link to the survey, where you can put some feedback for the sessions and for the event overall. I think, yeah, that's all for now.
And hopefully we will see you next year, probably not online, but offline in Poznań on the 20 and 21st September. So stay tuned with all the information that you can find on our page and our Twitter and also our Facebook fan page. So if you are looking for the information about the next year conference, it's all already there. The date is set up, and hopefully we'll see you all there. And it wouldn't be possible to organize the event without some support. So we want to thank 21CN for the support and sponsoring the event. And also we want to thank our strategic partner, testerzy.pl, which is a group of software testing passionates. And that's why they decided to bring this excellent quality event to you this year, even though we cannot meet in person in Poznań. Hopefully we'll do this next year.
Yeah. Olga, Ola, thanks a lot for the time.
Thank you, Michał.
And yeah, thanks, folks. See you.
Thank you for all the participants. It's great to have you here.